We tend to look at the world map and assume the coastlines are permanent. But some of the land masses beneath our feet are entirely human inventions, solidifying out of the ocean because we reached a point of absolute necessity. The extremes of this engineering are staggering. High in the Andes, there are entire communities living on floating islands woven from edible grass. Meanwhile, in the Persian Gulf, developers constructed a single luxury resort using a volume of dredged sand and rock so massive it could form a wall that circles the globe 3 times over. This points to a persistent friction in how we live. Natural, habitable land is strictly finite, but human ambition and our population are not. When we run out of room, we play God with geography and build our own. These artificial islands offer a physical record of our shifting priorities. By looking at what we build out of the water, we can trace exactly how humanity's motivations and problem-solving strategies have evolved over centuries. For centuries, the indigenous Uros people of Lake Titicaca have maintained their independence by living on floating, mobile fortresses. These islands were built specifically to escape the expansion of the aggressive Inca and Coya empires. The buoyancy relies entirely on the native totora reed. Because the bottom layers submerged in the lake constantly rot away, the Uros must painstakingly cut and weave fresh layers of reeds onto the surface every few weeks to keep their homes afloat. A similar tactic solved a growth problem for the 14th century Aztecs. To feed a rapidly booming population in the middle of Lake Texcoco, they engineered chinampas, rectangular enclosures in the shallow water filled with mud and decaying vegetation. Over time, the roots of these floating gardens anchored directly into the lake floor. That highly fertile, stabilized mud formed the solid foundation for Tenochtitlan, laying the groundwork for the sprawling metropolis of modern-day Mexico City. That drive to literally create room to exist scaled up massively in the 20th century. The Dutch secured their own survival by reclaiming the Flevopolder from a shallow inland sea. Using a complex network of dikes and massive pumps, they engineered a 374-square-mile expanse of land to accommodate new cities and agriculture. For the vast majority of our history, moving earth and water was a desperate measure. We terraformed to secure our basic existence, creating physical barriers against hostile neighbors or fighting off a total lack of space. As industrial global populations exploded and flatland near major hubs vanished entirely, cities were forced to push massive, critical infrastructure directly out into the water. In the 1960s, Montreal needed a spectacular venue for the Expo 67 World Fair, while simultaneously digging out tunnels for a massive new subway system. Planners merged the two problems, transporting 15 million tons of excavated rock and soil into the St. Lawrence River to sculpt Ile Notre Dame. Decades later, Hong Kong faced an aviation crisis. Hemmed in by mountains, engineers engaged in an extreme feat of terraforming. They completely flattened the small island of Cheklop Kok, using millions of cubic meters of dredged sand to expand it into one massive, flat aviation platform. Japan faced the same deficit of mainland space for the city of Osaka. Their solution was Kansai International Airport, a multi-billion-dollar aviation hub built entirely from scratch in the middle of Osaka Bay. Looking at this cross-section of Kansai Airport reveals a significant engineering obstacle. The incredible weight of the massive seawall and the runway is severely compressing the soft clay seabed underneath it. Since construction began, the island has already sunk more than 38 feet. Engineers anticipated some settling, but not at this rate. Now, the airport survives through continuous mechanical intervention. The terminals rest on adjustable hydraulic jacks, and crews are locked in a wildly expensive battle to constantly raise the seawalls against the encroaching ocean. Kansai exposes the structural vulnerability baked into these massive projects. Creating new land solves an immediate spatial crisis, but it locks us into an endless, expensive war against natural physics. By the 21st century, the motivations for island building shifted. We stopped solving civic infrastructure problems and started using the ocean as a canvas to project extreme wealth and political dominance. The construction of luxury havens like Dubai's Palm Jumeirah requires staggering, earth-scarring efforts. To ensure the artificial structures blended with the environment, developers bypassed concrete and steel, opting instead to dredge 94 million cubic meters of sand from the seafloor and quarry 7 million tons of natural rock. In Doha, developers constructed the Pearl Qatar directly over one of the region's most prolific historical pearl diving beds. It operates as a lavish, hyper-modern economic monument, designed from above to look like a string of pearls, in a nod to the grueling labor that originally built the nation's economy. But expanding landmasses carry severe environmental costs. With no room for landfills on its natural atolls, the Maldives intentionally filled a pristine coral lagoon with countless tons of municipal and industrial waste, creating the toxic, smoking ground of Thilafushi. And in the South China Sea, the practice has been aggressively weaponized. Massive dredging fleets are pumping concrete and sand directly onto submerged, fragile coral reefs. They are actively transforming open water into heavily militarized, unsinkable aircraft carriers, equipped with deep-water ports and radar installations. This modern era demonstrates a dangerous overreach. What began as a tool to cultivate food and secure living space has turned the open ocean into a permanent battlefield for territorial aggression, leaving irreversible ecological ruin in its wake. There are rare moments where engineering and ecology manage to align. When Denmark and Sweden built the Øresund link, they constructed the artificial island of Pebberholm as a simple transit halfway point. But scientists deliberately left the rebel completely bare. Over the next 2 decades, visiting birds and the wind carried seeds to the isolated stretch of dirt. Without any further human intervention, Pebberholm evolved into a thriving, strictly protected ecosystem, hosting hundreds of rare plant and insect species. Passive projects like this reveal a potential harmony between engineered spaces and the natural world, but they remain rare exceptions to our dominating industrial approach. Humanity is defined by a refusal to simply adapt to an environment, choosing instead to force the landscape to accommodate its specific needs. We possess the engineering power to draw entirely new lands onto the world map, but as we continue to push further out into the water, we are discovering that we can never fully escape the physical and environmental consequences of the worlds we choose to build.